Unit 7, Circles, Lesson 1, Circles, Circumference, and Measuring Angles and Arcs. Your objectives for this lesson are to identify segments of circles, calculate the circumference of a circle, determine the measures of major arcs, minor arcs, and central angles, as well as to calculate arc length. Okay, so starting off, a circle is the locus of all points in a plane that are a given distance, called the radius, from a given point, which is called the center. Now, I know that this word locus seems a little strange to you. It's probably a new word, but locus really just means group or set. So locus means group or set. And this is your circle. So if I called this circle Q, because we name a circle based on its center point, I could then write this as circle. So draw a circle, put a dot in the middle, Q. Or I could write out the word circle and write circle Q. So this is circle Q with center Q. And then we have the radius here. I could call the radius R. It might be 4 units, it might be 12 units. But basically, every radius is the same distance from the center. That's what a circle is. Some special segments that you have in a circle. First of all, the radius, which we just mentioned. So a radius has one endpoint on the center of the circle and one endpoint on the circle. So on the circle means that it's on this black line going here. So this is a radius. The plural of radius, so if I have 2 or 3 or 4 or however many, would be radii. This is radii. Next, we have a chord. So a chord is something probably that you haven't seen before. And it is a segment that has 2 endpoints on the circle. So both of its endpoints are on the circle like this. So this is a chord. Then lastly, something that you probably have seen before is the diameter. So a diameter has both endpoints on the circle like a chord, but it passes through the center point. So this is a diameter that I just drew. Let's see if I can write this way. Diameter. And a diameter is a special type of chord. So all diameters are chords. And it's really 2 radii put together straight across the circle. Okay, so something important for you to remember would be that diameter is 2 radius, or 2 radii, or 1 radius is the diameter divided by 2. These are very important. Okay, example 1. Name the circle. Well, looking over here, I know I named the circle based on the center point, and I see the center is O. So I'm going to call this circle O. Name the radii of the circle. So I'm going to name all of the radii on the circle here, which means everything that touches both the center and the circle. So I see one right here. This is segment AO. You could also have called this OA. The order doesn't matter, so you could name the center first or second. Next I have DO. So this is DO here. This one I could call CO. I'm going to write though OC so you can see it goes both ways. And OB. If you want to say BO, that's cool too. Okay. And C. Name the chords of the circle, and I want to name all of them. Well, down here I can see DC has both endpoints on the circle, so DC. If you want to say CD, that's fine too. And then AB is a chord. So you might be saying, well, AB is a diameter. Yes, AB is a diameter because it passes through point O. However, both of its endpoints are on the circle. That means that it is a chord. Circumference. Circumference is the distance around the circle. So this is like perimeter before a circle. You have two different formulas for circumference. This one is circumference, or C equals 2 pi r. So C is circumference in both of these formulas. Pi, remember, is a constant, and it's about equal to 3.14. In this class, we're not going to use 3.14. We're actually going to use the pi key when we make calculations on your calculator. And R stands for radius. So the circumference is 2 times pi times the radius of the circle. Or, since 2r is equal to the diameter, you could also say that the circumference is pi times d, which is the diameter. Okay, and again, circumference is the distance all the way around the circle. Example 2. Find the circumference of the circle to the nearest hundredth. Let's just say to the nearest hundredth. Okay, well, I see here in my diagram, I have this 13 centimeters, and the segment goes from the center of the circle to the edge of it, which means I have a radius. Since I have a radius, I want to use my formula that uses radius. So C equals 2 pi r. Okay, so C equals 2 pi, and now let's just plug in the r, times 13. Now, in case you're not familiar with where the pi key is on the TI calculator, this is what you're going to do. 2, then pi, you hit second, and then the little caret key, it's underneath clear. You should see pi written in yellow. So 2 pi, and then my r is 13. You can write times in if you want to. You can just write it this way also. So I get 81.68 is rounded to the nearest hundredth. Remember, hundredth is 2 decimal places. So 81.68, my unit is centimeters. Just plug it in. Okay, lots of stuff on this slide. So a central angle is an angle whose vertex is at the center of a circle. So if we have a central angle, center of the circle, central and center go together. The sides of a central angle are radii. An example of a central angle on this circle would be angle HEC. So you can see, if I had angle HEC, that the vertex is the center, which is at point E, and the sides HE and EC are both radii. CEF, FEG, GEH are all also central angles. So any angle that you're making here would be a central angle. And a central angle separates the circle into a major arc and a minor arc. Basically, major arcs and minor arcs. Well, you probably know already that there are 360 degrees in a circle. A minor arc is less than half of the circle. So 180 degrees is half of 360. So a minor arc is less than 180 degrees, or half the circle. And it is the same measure as the central angle. So right here, if I had this central angle and I said it was like 100 degrees, that could be 100 degrees. Then this is the central angle, and in green I'll show you the minor arc. So the minor arc is the portion of the circle. So it's this arc shape on the circle. Okay, this is my minor arc. It's like if I took the circle and I cut part of it out. Oh, sorry. And the measure of this arc is the same as that angle, so it's also 100 degrees. Then a major arc is more than half of the circle. So this is more than half the circle, between 180 and 360 degrees. So if what I put in green here is my minor arc, then what I'm trying to outline in red is the major arc, okay? So arc HC is my minor arc, and in red I could call this arc HGC is my major arc. Now typically you do use 3 letters to name a major arc and 2 to name a minor arc. And you want to include both the endpoints and 1 point that you pass through on the way. So HGC, this could have also been HFC. Okay. A semicircle is exactly 180 degrees. So this is exactly half the circle. Exactly half the circle. Okay. This says that 2 minor arcs are congruent if and only if their corresponding central angles are congruent. So basically, they have to be the same measure to be congruent. And if you, the measure of an arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. So basically up here, if I had that, what was this talking about, arcs? Yeah, okay. So if I have this green arc, I know it's 100 degrees because the angle is 100 degrees. If I know that this one is 90 degrees, that means that arc CF would also be 90. So I could figure out the measure of HCF by adding those together. We'll see an example of that. Okay, example 3. AC is the diameter of circle R. Find the measure of arc AB and the measure of arc ACB. Okay, so arc AB is right here, just going the shortest path from one end to the other. And I know the central angle, ARB, is 42 degrees. That means that the arc is 42 degrees. Okay. And then ACB is the other way around the circle. Since the whole circle is 360 degrees, I can just subtract 42 in order to get the measure of ACB. So this is going to give me 318 degrees. So the measure of arc ACB is 318 degrees. And you always have this little rainbow looking thing over the letters when you're talking about arcs, so don't forget to draw that. Okay, arc length. An arc is a part of a circle. We've been over this. Its length is a part of the circumference of the circle. So your arc length formula then is right here. L, which is the arc length, equals x divided by 360, and x is the central angle measure. Times 2 pi r. And remember, r stands for radius. You can see that all drawn right here. So L is the arc length, x is the number of degrees in the central angle, and r is this radius here. If it helps you to remember, looking at this formula, 2 pi r is the whole circumference, okay? And so you're looking at how many degrees am I looking at out of the total circle, so x out of 360, and then you're multiplying it by the circumference. So this is kind of like it's a percentage of the circumference. Example 4, and this I think is our last example. Okay. Find the length of arc AB, round to the nearest hundredth. Okay, so I'm using my arc length formula. L equals x over 360 times 2 pi r. Okay, so L is, well, where's AB? AB is here. Okay. So the central angle is 135. So I'm going to put in 135 for x times 2 pi, and my radius is 8 inches. Now I'm going to grab a calculator. Okay, so we have 135 divided by 360, and then times 2 pi, remember second caret for pi, and then r is 8. So I get 18.85 is to the nearest hundredth. My unit is inches. And that is how you calculate arc length. Yep. Okay, so that wraps up lesson 1 about circles.